What I want us to talk about first is the idea of a function. Now, a function is like a machine, okay? You put something into the machine goes rah, 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 and spits something out. You ever watched a hay baler? What's a hay baler? A hay baler, a hay baler goes along behind the tractor. It's hooked to the tractor, and it picks up the hay that's been rode up, and it makes either rectangular, like shoebox shaped bales of hay, or big round bales. Okay, so it takes in something, it does stuff to it, and then it spits something out. Okay, that's what a function does, and the function of a hay baler is to bale hay. All right. Now, I give you a function f of x. I don't want you writing anything. I just want you thinking with me for a little while. I give you a function x squared. Now, I don't want you writing down anything, not till I tell you. Now, I cannot draw, so those of you who can, you can laugh quietly inside your head at me because this is bad. But this is my machine. It looks sort of like a funky cactus or something, or a teapot. I don't know what it looks like. Now, an elephant. All right, okay. Now, this function, this machine is called f. Okay, in the hay field, your function is called hay baler. This function is called f. Well, what does it do? Well, to whatever is put into this machine gets squared. Okay. So, I put in 2. And remember, this function, this machine, whatever you put into it, what's going to come out is that thing squared, okay? So, 2 goes in. What spits out? 4. Good. 5 goes in. What spits out? 25. -6 goes in. What spits out? 36. That's a function, okay? And we write it like this, so we don't have to write the machine and we don't have to do all that crap. So what we do is we say, all right, f of 5 means you're going to put 5 in, and what's going to come out? 25. If I put in -2, what's going to come out? 4. So instead of doing the machine picture, I can just write it like this. Input, output. Are you with me so far? Now, let's keep the same function for a little while with this beautiful machine that we have. Yeah, don't tell your art teachers how bad this is. You're just gonna think it's wonderful, and you're just gonna pretend because that's what you're gonna do because you're kind people. What if I put in a? Right. Right. What if I put in 2p? 4p squared. 4p squared. What if I put in r? R squared. What if I put in, you ready? C plus 2. Right? Because didn't we just take what we put in and squared it? And you know what this means. FOIL what? C plus 2 times C plus 2. Right. But I'm happy if you leave it like this. That's fine. You can leave it like this. Go ahead. Now, I want to show you. I want to show you if we put this in. Let's see what it looks like here if we don't use the machine. It looks like, what am I putting in the machine? So you write f of c plus 2 equals, now everywhere I see an x, that's what it is, right? C plus 2 quantity squared. Now, what if I put in 3b? Then how would I write it this way? F of 3b, good, equals, and I could write it like this. Whoops, not like that. I could write it like that, correct? Because we just took whatever I put in for x and I squared it. But you know that that also is 9b squared. Okay? Now, are you okay so far? Now, all right, I'm going to make 2 watering cans this time. That's just so bad, but okay. And then my husband's an artist. He has an art degree. No, it's totally okay. I go to art museums. I love art. I just can't do it myself. Now, how do I want to do this? I have it written down. This machine is a function called g. Well, what does g do? Well, g takes whatever comes into the can, into the machine, and squares it. Now, this machine is f. Now, what does f do? Well, f takes whatever comes into it and does that. So whatever comes into f goes in, that's right. So what if 3 came into f? 6 minus 1 is 5. Now, yes, I just made it up.
Oh, okay. So it's not always going to be.
No, I'm making them up. Now, I'm going to put 3 in here. What comes out? And then I'm going to let 9 go into this one. 17. Right? Now, what if I let no. What if I let -1 go into G? And so positive 1's going to come out. And then I let 1 go into F. Now, how in the world could we write mathematically what we just did? What did we do first? Did we do F first or did we do G first? So here's what we did first. We did G of X, didn't we? We put something into that machine G and something came out. And then what did we do with the something that came out? We put it into F. Now I want you to take a look at that. That's exactly what it says. Say it again. That says F of G of X. Ladies and gentlemen, you just did a composition. Now, so let's do with these two functions that we've got up here. Let's do one. Now I'm going to write f of g of 4. Now, how can you look at this and tell which function you do first? The inside, because which one are you doing to 4? G. So we're going to go up here and we're going to do g of 4. We're going to g it. So we're going to g4. Sounds like bingo. What comes out? So, look at this. What is g of 4? 16. So what's going into f? So look how we wrote that. Do you buy that? We did the g of 4, and we got 16. Remember, what comes out of g is what's going to go into f. Now let's put the 16 in to f. What comes out? 16 times 2 is 32, minus 1 is 31. There's your answer. That's a composition. That's all there is to a composition. You like my picture?
Yeah.
Thank you. Okay.
Finally.
Okay. Now, let's go to your notebook. Oh, dang. No, it's going to be just what we're doing. Just what we're doing. Now, on the first line, I want you to write f of x equals 3x plus 1, and g of x equals x cubed. It's quite a few. We're going to do quite a few. Don't write big. Now, here's what we're going to do. Our first problem, we're going to do f of g of 2. Now, I want you to write down, not across. Put these two the way I've got them, yeah. And then on this problem, we're going to go down. Which machine gets run first? G gets run first. What is, question? No? What is G of 2? 8. So what's going to go into F? 8. So this is F of 8. What is F of 8? That's right. There's your answer. And you just did a composition. Go ahead. Yeah. I go, see, what's happening to the 2 first? The 2's being G'd first. So I got to go G it. Now this is going to sound nasty. And then whatever comes out of G, I got to F it. Okay?
Can we use different I want to watch the issues. I have a serious question. If we want, can we change the
No. No. Keep my letters. Keep my letters. Okay. Number 2. Beside it. Yeah, you're going to do number 1, number 2 here to the side, and number 3 to the side of that. And that's what's going to be your first. Yeah. I got gosh danged. All right. Now, what function works first? F works first. Okay, hang on.
Slow down.
Hang on.
I can't.
All right. We're going to do F of 2. F of 2. 3 times 2 plus 1 is 7. So What's going to go into G? 7. So you're going to write equals G of 7. Now, what's going into G? 7. 7 times 7 is 49, and 49 times 7, 343. Good. Now you have one more, and that's going to go to the right of number 2. We have one more of this kind of problem. All right. The third one here, f of g of 0. F of g of 0. So what is g of 0?
0.
Because 0 cubed is 0. So you're going to write f of 0. And what is f of 0?
1.
Now I want you to go down to like your next row. We're going to use the same functions. Now the instructions are going to look different, but here's what you're going to write. Find, sorry, I lied to you. We're going to use different functions. But on the next line, I want you to write this, find, and this looks funny. That's F with a little open circle. Put it raised up. Don't make it like where a decimal is. Raise it up. It's exactly like a degree symbol. Yep. And G of F and the domain. No. Now, let's talk about that. If you see this, or if you see this, that's multiply. When you see that little open circle, let me explain to you what this means. When you see this, it means f of g of x. And when you see this, it means g of f of x. That's what they mean. Many people call this Fogg and Goff. Now, I don't like writing them this way. I would rather write them this way, but they mean the same thing. Yep. All right. Yeah, I know. I'm sorry. I know. Okay, so on number 1 here. Oh, wait. I need to give you new functions, don't I? All right. I got to erase this because I'm not going to have enough room. So you know the instructions. You wrote those down. Dadgummit. All right. Karen got the giggles again. All right, good. F of x equals 5x plus 2. G of x equals negative 4x plus 1. Now, we're going to find Fogg, and then we're going to find Goff, and then we're going to talk about their domains. All right, here we go. So let's just write number 1, f of g of x. You're gonna have this problem, and then you're gonna have another problem to put to the right of it with 2 new functions. So don't let this go farther than halfway across that. I told you to write small. Oh. All right. Now, do you notice that what's right here is not a number? Now, I don't want you to worry about that because you're going to do the same thing as what we did before. Let me show you what I'm talking about. Let's, oh my goodness. This is just a mess, isn't it? Let me show you what I'm talking about. Get rid of all this hoo-ha here. And all right, f of x was x squared. Now, what if we put r into that? What comes out? R squared. What if we put y plus 3 into that? Y plus 3 is getting squared, right? What if we put s cubed into that? Right, because it's going to be this squared, right? Which is s to the 6th. What I'm saying to you is it's okay to put variables in there. That's not a problem. You can absolutely do that. Now, which machine do you do first? Do you do the machine F first or do you do the machine G first? Because G is inside. It's the first one that happens. Well, what is G of X? No, look here. Look here.
Oh,
That's what G of X is, isn't it? So, since G of X is this. So I'm going to write F of, I want you to write exactly what I'm going to write. And write it down. Okay, now take a look at that. Do you understand what I just did?
yes.
This says G of X. Now remember, you got your no, thank you. G of X equals negative 4x plus 1, right? What's going in? See what's going in? X. And if X goes in, this seems silly. If X goes in, what comes out? Negative 4x plus 1. Because that's what it is. Yeah. So, this is what's going to go into F. So, here's what you got to think. How do I write if this goes into F? Remember, if 2 goes into F, what do you do? I put 2 where X is, so what do I do to it? I do negative 4 times it, and then add 1. So that's what I'm going to do with this. Yeah, I would do, if I was putting that into this machine, I would do negative 4, it's the same function, never mind. Forget that I just said that. My function now, this is going into what function? F. So my function now, I'm getting faster and faster, and that's just worse, but now look what's going in. Negative 4x plus 1. How in the world do we figure out what comes out? That's exactly what you do. That's exact, and then we're going to clean it up. That's exactly what you do. So where did we put this? Where the X was, right there. Oh, I'm sorry, I just started erasing. So here's what you're going to write. This, negative 4x plus 1, is going right there. So you're going to have 5 times that plus 2. Now let's clean it up. What do you get? Negative 20x plus 5 plus 2 is plus 7. That's right. That was f of x, f of g of x. Now let's do, this one. So what machine runs first? No, this is still in question number 1.
Do you want to start it?
Yep. Put this one right next to it. This is, yeah. That's the answer. It said to find f of g of x and find g of f of x. This is the f of g of x. That's a good question. Is it going to be the same answer? That's a great question. Now, which machine runs first? F. What goes into F?
5x plus 2.
No, what goes into F? X. Well, what is f of x?
5x plus 2.
So what's going to go into G?
5x plus 2.
Aha, so you're going to write this. G of 5x plus 2. Well, here's G. Where is this going to go? It's going to go right there. So what are we going to write down? That's exactly what we're going to write down. Negative 20x minus 8 plus 1. So they're not the same, are they? Similar, but not the same. That's not always going to happen. It did this time. Won't always happen. Now, the only hard part of this stuff is the domain. So, here's what I want you to remember. Will you please remember? Do you remember when we did square root? When that root was even? Then we had domain issues, didn't we? Because if you remember, come on. Do you remember when we graphed y equals square root x? And our points, square root of 1, square root of 4, square root of 9. Remember that? And the points were like this. Now we're just talking domain, we're not talking range. Does domain go left, right, or does domain go up, down? So does my arrow from this end point, do I go left or do I go right for the rest of my points? Is that greater than or less than? So this says for the domain, all x such that x is, and what's the x value of that point right there? Okay? Ladies and gentlemen, if you had a square root, remember you had domain issues, right? Right? Remember? And if you had a cube root, we didn't have any domain issues because they were the same. It was all real numbers. Okay. Now, if I give you this, do you know what that looks like? It's a line. What is f of x another name for? Y. That just says y equals x. That looks like this. What's the domain of that? All real numbers. All real numbers. Ladies and gentlemen, if you have just a nice polynomial, and remember a polynomial like x squared plus 3x minus 5, or 2x to the 4th power minus plus 7x, or negative x to the 5th plus 2. If you have a polynomial, the domain's all real numbers all the time. Can you remember that? If you just have a polynomial, the domain is all real numbers all the time. So, let's go back and look at what we had. What's the domain of f? This is y equals 5x plus 2, right? Is that a polynomial, 5x plus 2? It is. Do you remember what kind of polynomial is it? What's the biggest degree? 1. Is that constant, linear, quadratic, cubic, quartic? Which one? No, it's not constant. Linear. Constant would be like just a number, 4, -7. This is a linear function. This is a polynomial. What about g? Yeah, it's also linear because the biggest exponent is 1. It's a polynomial with how many terms? 2 terms is a binomial, right? It's a linear binomial. Now, this one's real easy. Domain's all real numbers. I'm going to say something, and then we're going to have to say it about 156 times, okay? The domain of a composition. You start with the domain of the inside function, okay? And it goes all the way through with you. What was the inside function here? G. What's the domain of G? All real numbers. That's going all the way through the problem with us. So the domain of this thing is all real numbers. Okay. Yep. Did y'all number those 1 and 2?
Yeah.
Just number them 1, number it 1, and then number this one 2. Now, you can put 1a and 1b if you want, yeah. Now, here are your 2 functions. F of x is square root x. G of x is 2x. Now, I want you to try it. I want you to find f of g of x, and I want you to find g of f of x. While I talk to Miss Locke. Does anybody have an answer for the first one? Okay, here we go. What's g of x? So what would I write down? What would my next line say? F of 2x. Good. Now, my function f, remember, so my machine, right? And so my machine, okay? If you don't know what to do, draw a machine. Let's just call that, let's just say I'm Picasso, okay? It's a dragon. Well, all right. So here's my function f. Yeah, see, now he's going into a mouth, okay? That was all planned, right? Whoops. Okay, is square root x. Jiminy, pretend that's square root, okay? Now, look what goes in. 2x. What's going to come out? The square root of whatever went in. It's this. No, great question. No plus or minus. The reason right, you didn't do the square root. This one says positive. And remember, this is a function. If you graphed plus or minus square root of x, it would be a parabola lying on its side, which is not a function because it fails a vertical line test. Okay. All right. Now, did you do g of f of x?
Yes.
Oh, was that easier than the first one?
Pretty easy.
Okay. G of, what's going to go into g?
No.
What's f of x? So I've got my, so we're going to be Picasso again. Thank you. So this is function g, and that's 2x. Look what's going in. Square root of x is going in. It's 2 times the square root of x. Great. Right. I'm going to replace whatever sits right here. It's going to be replaced by that. Okay. Are y'all getting this? Now let's talk domain. Oh, wait a minute. What's the domain of square root of x? We did that we did that just a little bit ago. You remember what the domain was? Now, the domain of this function is, I'm not going to write the whole thing, I'll just write that part. Now, hang on. What's the domain of, what's the domain of G? All real numbers, because this is a polynomial. All that's happening that's multiplying by 2. That's all real numbers. All right, now here we go. This, again, this is the hardest part, so we're going to have to really work this part. Let's look at this one first. Did the inside function have a certain domain?
Yes.
Sure did. That. And that x greater than or equal to 0 has to stay through the whole thing. So the domain of g of f of x is going to be this. The domain of the inside function is going to stay with the problem the whole time. Now, let's take a look at the other one, f of g of x. What was the domain of the inside function? All real numbers. That's going to stay with us all the way through. So you may go right here to the end and think, oh, so the domain is all real numbers. But the problem is on this one, is something happened in that function machine, in that hay baler, that caused the domain to have to change because it got square rooted. What are the only numbers I can take a square root of? What are the only numbers I can take a square root of? 0, positive numbers, and 0, right? I can't take the square root of a negative because what do I get when I take the square root of a negative? I. So since that function got square rooted, you have to say, well, snap, it was all real numbers, but now something happened, and what the only numbers I can take the square root of are the domain's going to take you a little time. I don't want you to sweat it. The domain's just going to take a little time to work out, okay? Now, I want us to work, let me see here, go below. Just a minute, I'm looking. Now, I want you to just go below this one. We're going to do kind of a part C. And you're going to find, oh, snap. Never mind, we're not going to do a part C. Okay. We're going to start over right here. Now, do you have maybe a third of the page left? Well, daggum. Okay. So let's talk about how to deal with your page right now. Hopefully, you got some space left. Because I told you to write little. Hopefully, you did those first 3 problems, right? And you did those last 2 problems. And I hope you've got enough room for one more f and g, and then do f of x and f of g of x and g of f of x. That's what we've got left. Okay? All right. So I'm going to give you 2 new functions. F of x equals x squared. G of x equals negative 2x plus 5, all divided by 4. Now, first of all, I want us to think domain. Look at f of x. Is that a polynomial? Yes. And what's the domain of a polynomial? All real numbers. The domain of that thing is all real numbers. Now look at this thing. Is this a polynomial? Yes. This is a polynomial because there's not a square root, there's not a root, and there's not an x in the denominator. Okay? So what's the domain of a polynomial? All real numbers. So what do you think the domain of our answers are going to be? If both of those are all real numbers, I'm pretty sure the answer is going to have a domain of all real numbers. Question? Okay. Now, let's do it. Let's do f of g of x, and let's do g of f of x. Here we go. You all right? We're going to do that, and we're going to do this. So you're going to have here and here, okay? And those are the last ones we're going to put on that page. Right? Yeah. Okay. Here we go. F of g of x. Which one goes first? What is g? So what I'm going to write is f of now remember I got this function called f, and that function, what does it do? Squares whatever goes in. What goes in? What? This. So this goes in. And what happens to it? It gets squared. You can leave it like that. And the domain, you can, Jacob. And the domain. Yeah, can I scroll up? Yes, I can. Let's do g of f of x. Which function goes first? F. What is f? So what's going into g? So write down g of x squared. Now remember, the function g does this. So you put x squared in. What spits out? Negative 2x squared plus 5. That's it. Because they didn't have x's. What's the domain?